Session 2.1, Visualizing Variation in Numerical Data. Remember, we do have two types of data. First one is a categorical. Second one will be the numerical data. In this chapter, we're going to learn how to use the graph to distribution our numerical data. First, what is a distribution? Any collection of the data will have variation within the data. Remember on the chapter 1, we used the example, draw a circle on a piece of the paper. And then I try to draw 3 circles on it. And I say, they may be slightly different size or different version of round. So this is the example of variation. And the most important tool for organizing the variation in data is called the distribution of the sample. The distribution of the sample is a simple way of organizing the data. Okay, when we have a whole bunch of the data, it looks really messy. And then we can't see anything from a whole bunch of the data. And that's why we need to know how to organize it. 3 main components of a numerical distribution. Number 1, shape. What does it look like visually? So we do have a different shape for the distribution. Later on, we're going to talk about it. We do have a normal distribution. We have the skew to the right, skew to the left, or even uniform distribution. We're going to talk about this part later. Center. Center means the typical value. You could think about it like the most occurred data in the collection of the data. Number 3, variability, horizontally spread. So we want to know is all the data is going to be put together really close to each other, or they're going to be spread it out. So this is the 3 main components of the numerical distribution. Distribution, look at this example. Here are some word data from the NCAA available online. This set of the data shows the number of goals scored by first-year NCAA female soccer players in Division 3 in the 2012 season. We do have a whole bunch of the data here. We need to see the distribution from the data here. And distributions record all observed data values. So this is talking about we're going to observe each data and then write it down in here. Seeing the patterns in the raw data may be difficult. So we need to find a way to organize the data here. We can organize the data using the frequency table. So this is called the frequency table. You could see the value here talking about the data. And then you're going to see the frequency. Frequency means count of how many times the value occurred in the collection of the data. For example, I do have a 1, 9 in here. So that's why my value, the data is 9 and only appears once. And then I have 1, 2, 3, 4, 4, 11 here. I do have a 4 data, it's a 11 here. Okay, so this is called the frequency. And this is talking about the data value here. And I want you guys try to add it all up the frequency. We need to know total frequency. Means like how many total data do we have? Try to add it all up. Okay, we have total frequency 28. Means like we do have a 28 data in here. Keep in mind, frequency table lists all the data values with their counts. Okay, the counts talking about the frequency. Patterns may still be difficult to see. I only organize the data with the frequency table from now. So when I look at the table here, I could tell, oh, we do have the most data occurred here will be 13. We do have 5 of them. Then the second one will be the 16. We do have 4 times of it. Okay? But we still cannot see the patterns. Okay, when examining the distribution, use a 2-step process. The first one, visualize the data. You could think about it. The first one is going to be see it. Use a graph that effectively summarizes the data visualized. So using a graph, we can have a different graph later on. You can use a histogram, the dot plot, stem plot to summarize the data so we could easily to look at it. Using a picture to display the data will help us see the patterns. So we want to see the patterns. Remember I say you can see we may have the normal distribution, we may have a uniform distribution, or we could see if the data is going to be symmetric. Graph for numerical data include dot plots, histogram, and the stem plot. So remember this, when we're working on the numerical data, we usually use dot plot, histogram, and the stem plot. I will give you guys an example for each of the graph in here. Number 2, summarize the data. The shape is there symmetric. So we want to see if they have a symmetric, it's going to be the left hand side, go to the right hand side. The center, is there a most common value? Okay. And then spread, are any data values far from the rest of the data? This is talking about the outliers. What is the meaning of outliers? For example, I have all the data here. This is the scatter plot. One dot represent one data. So you could see all the data is going on like this way. But I may have one or few data is far away from the majority, like this. Okay, you can see my scatter plot, all the data go on like this directions. Only like 2 data is far away from the majority. And we call these 2 data are outliers. Okay, outliers. Visualizing the data to go. Keep in mind, using a picture to display the data will help us see the patterns. And different visual representation capture different aspects in the data. The picture must record the data values, indicate the frequency count of the data values. So this is our goal to visualizing the data. Okay, the first one, I need to teach you guys for the numerical graph. It could be called dot plots. Okay, the dot plots. We'll be using the same example from here. Okay, we do have all the data. We do have the frequency count in here. Record the data values on a number 9 with a dot above the number 9 for each data values observed. This is called the dot plot. For example, you could see I do have a 1 dot in here. This is a 10, so I could say this is a 9. Number 9, data 9, we do have a 1 dot, means I only have a 1 frequency here. And then here, 10, and then that will become 11. So from the 11, I have 1, 2, 3, 4. I have 4 dots in here. So you can see I do have the data value 11 and then the frequency will be 4. Okay, so and then another one, the 12, I only have a 1 dot here. Okay, and then you can see I do have the 21, the data 21, I do have a 1 dot. So 21, I only have a 1 dot. And then far away from the majority. Okay, there's a 35 in here, only have a 1 dot. Remember how to call this data? This is called the outliers because this dot is going to be far away from the majority. Okay, this is the dot plots. You guys need to know how to construct the dot plots. On the exam, I may give you guys an example. I will give you the frequency table here and ask you guys construct the dot plots. And then based on the dot plots, you guys can answer the questions. Okay, just like this one. I give you guys some time to work on this question. Okay, let's try to work together. Top part of the cost of the books at the college bookstore. Okay, so this is the book cost in here. How many textbook cost 150 or more? Okay, 150 or more. So you could count 1, 2, 3, 4. Okay, so 4 textbook cost $150 or more. What percent of the textbook cost $50 or less? Okay, $50 or less. So we have 1, 2, 3, 4, 5, 6, 7, 8. We do have an 8 textbook here, but they're looking for the percentage. So we have the 8 over how many total textbook that we have in here. You should count all of them. So you should find 23 textbook for total here. So that will be 8 divided by 23 times 100%. Okay, so one more time. We are looking for the percent of the textbook cost $50 or less. So from 50, 1, 2, 3, 4, 5, 6, 7, 8. We do have 8 textbook that cost $50 or less. And then over the total number of the textbook here, which is going to be 23. Okay, number 3. Are there any unusually expensive or inexpensive tests? So this is talking about the outlier. Okay, outlier, remember the definition? The data which is far away from the majority. So it's got to be like this one, 300, right? So the test that costs close to 300 may be unusually expensive. So you guys know how to construct the dot box here and use the dot box to answer the questions. And then we're going to talk about the advantages and disadvantages. Advantages: show individual data values and helps investigate the shape of the distribution. So here, for this example, we can't really tell the distribution here. Okay, but we could see all the textbook. The price is gonna be from 10 to 150 or 160. Okay, this is the price in between that. And then you could see individual data clearly. This is the advantage using the dot plot. Disadvantage: not as common as histogram and other graph. And not great for the data with too many individual data. So I would say nowadays people seldom use the dot plots. We usually use the histogram instead of using the dot plots in here. And also, this is not good for the data with too many individual values. So we may want to use, for the distribution, they do have a lot of the repeated values. Okay. Second one, the second graph, histogram. Histogram is really common, okay? You should see that on the math class already. So first one, the group data into intervals called the bins, the width of the interval. Or you could say the bin width in here, okay? We're gonna have the example later on and I'm gonna talk about this guy one more time. Count how many data values fall into each bin, okay? And each rectangle has the following properties. First, consecutive bins touch. You will see the histogram is going to be touched to each other. First value in each bin is recorded on the horizontal axis, and the height of each rectangle corresponding to the cards. So the y-axis here, they are talking about they will be using the frequency or relative frequency. So this is going to be the example. So one more time, this is the histogram. On the y-axis, we usually use the frequency or relative weak frequency, either one, okay? And then for the goals here, this is talking about the data value. And they're talking about the bin width. It's talking about like here. This is the bin width. And then one more things, the consecutive bins touch. So meaning that here they don't have a gap in between usually, okay? Most of the histogram, they will be touching each other. Here, this is the relative frequency, the formula. How you calculate the relative frequency? You'll be using that frequency divided by sum of all frequency. For example, I want to calculate the relative frequency here. That will be the frequency, which is 1, divided by the total of frequency. So 1 divided by 28, you have a 0.036. One more time. Second one will be 4 divided by 28. So you're gonna get 0.143. I want you guys use the calculator to finish this one. Take like 3 decimal space. And then after you guys done, I want you find sum of all relative frequency to see what did you guys get from here. Okay? Okay, check your work. Okay, so what is the sum of all relative frequency equal to? That will be equal to 1. Okay, so I want you guys remember this part. Sum of the relative frequency must be close to 1. Sometimes you may got like 0.9999 or 1.0001 like that way. It just because this decimal is here, wanting the decimal. But it's supposed to be really close to 1 or equal to 1. So on the exam, please double check your work. Add it all up to see it's going to be equal to 1 here. Changing the bin width. Remember, the bin width is talking about like here. Okay, so look at here. The bin width here, this is going to be equal to 3. 3 in here. You use the 12 minus 9 or 15 minus the 12 in here. So the bin width is going to be equal to 3. If I have exactly the same data, but now I'm changing the bin width into 1 in here, you're going to see they do have a different shape. You're going to compare this picture and with this guy. It looks like totally different, right? So it depends on what you're looking for and then to change the bin in here. And when you guys working on your homework, some questions, they do have a specific bin width in here. So you may want to follow the bin width with the picture on the homework. Note about the bin width. A width that is too narrow shows too much detail. Too wide hides the detail. So it really depends on what you're looking for and how spread out of your data. Most technology, the TI-84, choose bin width for an initial look at the data, but one should always experiment with adjusting the bin width to see if anything interesting appears. So sometimes you may want to change the bin width to see if there's too much detail or they may hide the details. Okay, histogram, advantage and disadvantage. Good for large data set. Okay, if you have a large data set, it will be really good to using the histogram. And how focus on the general shape of the data. So remember, I told you guys we do have 4 kinds of the shape that we need to pay attention for. The normal distribution, uniform distribution, skew to the right, skew to the left. We're gonna talk more about it in next sessions. Easy to spot outliers. Okay, so when you have the data far away from the majority, if you guys using the histogram, it's easy to find it out. Disadvantages. Individual data are not visible. And distribution shape affected by change in bin width. Remember, if we change the bin width to narrow, we will see too much details, right? Okay, this is the instruction how to use the TI-84 calculator to create a histogram. So you guys can follow the instruction from the notes in here. And I will use the example, the prefix example, to create the histogram using the TI-84 calculator. So you do have the TI-84 or TI-83 calculator in here. So first part, we want to input the data. So you're gonna go on the stat. Okay, number 1 added. So you could see I have a L1, there's nothing in here, and I have some data on L2 and some data on L3. I will teach you guys how to delete all the data in L2 and L3. So use the arrow. Go to the L2, I highlight this L2, and then I'm gonna click clear, enter. So everything's gonna be disappear. So go to same thing, highlight the L3, click clear, and then enter. So everything's gonna be disappear. So now I will input the data, the histogram here, the data into my L1. And then remember, this is the frequency table. So this means I do have a one value of number 9. So I'm gonna input number 9 here. Okay, click on the number and then click on enter. And then I do have a 4 of the 11. So I'm gonna input the 4 times of the 11 here. 11, first one, second, third, and fourth. Okay, 4, 11, and then I have a 1, 12, and then I have 5, 13. 1, 2, 3, 4, 5. Okay, and then I have a 3, 14. 1, 2, 3. And then I have a 2, 15. 4, 16. And then 2, 18. 2, 19. 2, 20. 121, 135. Okay, so I'm gonna highlight the last data. You can see on the data L1 we do have a 28 data. The last one will be 35. So it matched for the total of the frequency, 28 of the data. Okay, I could go back to the stat, and then I want to create a histogram. So you're gonna go to the second stat port here. You can see my stat port is gonna be turning off, okay, except the last one. So I'm gonna turn on the first one. Enter to turn it on. And then you do have a different type of graph here. So we want to create a histogram. So we're gonna go to the third one. Okay, this looks like the histogram. Enter. Okay, X list means the data you're gonna put it on L1. Okay, if you put it on the L2 or L3, that's fine. So L1, I'm gonna put second one for L1. You can see the bold word here. When I push second 2, that will be the L2. Okay, right now I don't need it, I want to put L1. So second 1 for L1. Frequency means how many data in this list. I will only put 1 in here because I already write down the frequency of the data onto the L1. Okay, once you're done, you're gonna click on the zoom and then click on number 9, zoom stat. Okay, you're gonna see the histogram. But then you're gonna say, hey, how come it's totally different from this picture? Because we need to change the setting. Okay, so if I want to get exactly same histogram like this guy, I'm gonna go to the window. The X minimum, talking about for the first rectangle here, what number is this one? That will be the number 9. And then X maximum, so X axis, what is the last one in here? So that will be 36, enter. And then what is the XSCL? It's talking about the bin width here. So this is from 9 to 12, which is going to be 3. Y minimum. From here, Y minimum, I would just set it equal to 0. We don't have the negative number for the y-axis. And then Y maximum. You could see the highest one, that will be the number 9. So I'm going to put 9 in here as well. Okay? So you only need to input from X minimum until the Y maximum. Okay, once you're done, you're going to click on the graph. Okay? It looks like about the same, right? So I could double check my work. I'm going to click on the chase here. You're going to see minimum 9, which is talking about here. Number 9, how many of them? We do have 5. So you're gonna see minimum 9 and the n equal to 5. This is talking about the frequency in here. And then I'm gonna use the arrow button, go to the right. Okay, 12 and n equal to 9. So 12 here, n equal to 9. The third one will be 15, which is gonna be 6. 18 and 6. This is gonna be 21 and 1. Okay? And then the last one, 0, 0 here. So that will be 33 and 1. Frequency is going to be equal to 1. Okay, right? Okay, and then you're going to see the next picture. They do have the same data, but it looks like different. So again, I'm going to change my window. So this time, I always look at the left-hand side, the X minimum, this one. So think about it, if this is 10, 11, 12, 13, 14, 15, right? So they do have a 1 unit for the bin width. So if this is 10, this point, that will be the 9 also. And then the last one, if this is 35, the next one here, that will be 36. And then the XSCL talking about the bin width here. This is about like 1 unit, right? So I'm going to put on the 1. Y minimum, I still keep on 0. Maximum, the highest one, I only have a 5. So I put 5 in here. Okay, right? So now, once you're done, you're going to click on the graph. See? Exactly the same thing. Again, if you want to see how many of the frequency for each bar here, click on the chase. Okay, one more time. Number 9, talking about this point, X minimum, 9, 1 unit. So n equal to 1. Go to the right, go to the right. Second one, that will be n equal to, X equal to 11, and n equal to 4. Okay, right? Make sure you guys know how to do it, because a couple of the homeworks, you need to create the histogram using the TI-83 plus or TI-84 plus. Okay, I show you guys one of the homework. Okay, let's look at this question. So use technology to create a histogram for the data. You're gonna see the data in here. You're gonna click on it. Okay, this is gonna be the data. So I'm gonna go back to my TI-84 plus. Do you guys see the grid here? So I'm gonna put second mode for grid. Now remember, I want to input the data. So I'm gonna click on the stat. Number 1 added. This time I'll be using the L2. Okay, so I'm gonna input the data onto L2. So 15, 15, 16, 10, 20, 20, 35, 7, 8, 41, 15. Okay, how many 12? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 already. 1, 2, 3, 4, 5. Okay, right? So here I teach you guys something new here. I do have my data on the L2. I want to sort it in order. So I'm gonna go to the stat. You could see number 2. I'm gonna click on number 2. I want to sort 8 with the L2. So I'm gonna click on second 2 for L2. Enter. Okay. Now I'm gonna go back the stat. You could see my data is sorted in order. Okay. Okay, now I'm gonna go to here, the second stat port to create histogram. Make sure you turn it off in here. The first one, I'm gonna enter, turn it on. And then one more time, I'm gonna choose the histogram. Enter. And then my data this time is gonna be on L2. So I'm gonna press second 2 for L2. Once you're done, click on the zoom. And then number 9, zoom stat. Okay, I can't find any picture it's gonna be similar to this guy. So what I can do, remember I'm gonna change my window. So we're gonna look at each picture here. You could see, okay, if this is 10, this guy is gonna be 5, right? And then remember we need to input the X minimum, talking about like this point in here. If this is 10, this is 5, this guy will be 2.5. So 2.5, enter. Don't put the 5 in here. 5 is talking about at this point. I need to find the X minimum is here. Okay? Just like the PowerPoint. Okay, the 9 talking about this 9 here. Okay. So here 2.5. And then the maximum, if this is 40, that will be 42.5. Enter. And then for each width, you could calculate the width in here. It's same idea from here, from the 5 to the 10, which is 5. And then the Y minimum, again, I'm gonna put it 0 here because we don't have the negative Y values. And then the maximum, we do have a 6, 7, and this is gonna be 5. I will try to put the highest 7 in here. Enter. Okay, click on the graph. Okay, click on the chase. You can see 2.5 talking about here. We do have a 2, n equal to 2. Second one, 7.5. He's talking about it here. We do have n equal to 7. And then we do have 12.5 here, which is gonna be 4. Okay, it's gonna be matched on this picture. So I'm gonna choose the C here. Okay, double check. And then final check. Excellent. Okay. Another graph, stem ports. Stem port also called the stem and leaf ports. Separate each value into 2 parts. The stem, the leftmost digit, and the leaf, the rightmost digit. Like the dot port, show all the individual data values. Very useful when technology is not available or when the data set is not too large. Okay, let me show you guys the stem ports in here. So this is also called the stem and leaf ports. Separate each value into 2 parts. For example, let's say I have a data 18, 22, 23, and 38. Okay, or I may have a 7, one more data. So if I want to use the stem port, what we're gonna do, we will have a line in here, and then the 7, since we only have a 1 digit, so we're gonna put the 7 here. And then 18, we're gonna separate into 2 parts. Okay, the left part here, the leftmost digit, this is called the stem. and then the rightmost digit here, we call this is the leaf. So on the line on the left hand side, we're gonna put the stem in here. So we have an 18, we're gonna have a 1 and the X in here. Okay, same idea for 22 and 23, they do have the same stem. So I have a 2 and then 22. So I have a 2 here and then I have the 3. Okay, keep in mind 2 and 3, this is the leaf. So I'm gonna put the 3 here. 38, I will have a 3 and then the 8 in here. Okay, so you could count how many data you have. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this is a really easy example to look at the stem port. I'm gonna show you guys the more difficult one, like here. Okay, so the stem here, we do have 1, 2, 3, 4, 5. We do have a 5, 1. So we could see 1, 2, 3, 4, 5. How many 2 we have? 1, 2, 3. So we have a 3, 2 here. Okay, until the 2 digits here, that's a 10. So it's going to be 1 here and 0. So we do have a 1, 10, 2, 10, 15, 17, right? 2, 10, 15, and 17. Okay, so this is called the stem port. You guys can switch it like this way, switch it to counterclockwise, and then you're gonna see most data is gonna be appear from here. Okay, so more data is gonna be appear from 1 to 10. Okay, I want you guys to try this one. Okay, hey, sorry, one more things. Make sure for the leaf here, you want to put the numbers in order. Okay, put it in order. So starting from 1, 2, 3, 4, 5 here, and put it in order. Okay. So for this example, they didn't organize the data in order, so you may want to do it by yourself. And also, 136, think about it. Which one is gonna be your stem? Which one is gonna be your leaf? Okay, try your work. Okay, try your work. Make sure you will put the number in order. Okay, and then at the end you should count how many data do you have. You do have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times 3, you do have 30 data. So you're gonna count here. Do you have a 30 digits in here? If not, means you make a mistake. Okay, right? This is called the stem port. Okay, so for these sessions, we learned 3 graphs for the numerical. First one will be the dot plot. Second one will be histogram. The last one will be the stem and leaf ports. Okay, we usually use the histogram. And make sure you guys how to construct the dot plot, histogram, and also the stem and leaf ports. You may have it on the exam. Okay, that's it.